All right, so we are starting a new unit today, and that's a unit on similarity. So you've got a new tab. So we are going to cut that, cut the extra off here, and then we're going to glue it in. Figure out what page we're gluing it on. Okay, so we finished on 93. So 94 is where we're going to glue that in. So label 94, unit 4. Okay, and it'll be blank, and then label unit page 95, unit 4, and that's where we're going to glue this tab in at. So page 95 is where this is going. Make sure it hangs off a little bit. Sadly, I made mine purple and purple this time, so it needs to hang off just a little bit. So it's actually a tab, and then we'll get started on the first lesson of this unit. All right, so we're going to start on 11.1. We're going to start with dilations today. Dilations are going to be on pages 96 and 97. You are going to have a foldable that goes on 96 and 97, so we're just going to go ahead and label them, and then start with those foldables. And I actually went ahead and labeled them before the video started. So 96 is 11.1 dilations. 97 is 11.1 dilations. And I'm going to put this side because it is actually a foldable. So they're attached with the video with your stuff. Okay. A dilation is a transformation, we've talked about that before, that can change the size of a polygon but leaves the shape unchanged. So it can make it bigger or smaller, but it's still going to be a triangle, okay? It's still going to be a right triangle or an isosceles triangle, but it is going to change the size of it. A dilation has a center, that should say of dilation, not or dilation, so let's change that to F. Has a center of dilation and a scale factor. Center of dilation and scale factor are important in this, which together determine the position and size of the image of a figure after a dilation. So first of all, we're actually going to kind of find this, talk about the pieces here of a dilation and all that. Okay. First of all, we are going to measure these sides. We're going to measure them in centimeters. So you're going to need a ruler that uses centimeters. So first, let's find the measure of AB. AB is 7 centimeters. If I were you, I'd pause the video and just measure it on your own. And by the way, I will tell you I'm going to kind of round up because I made a copy of this and did not think about the fact it actually dilated itself. BC is 4. Okay, instead of measuring them all out, I'm just going to tell you what I got when I measured 3.5, 2.5, and 2. If those are off a little bit, it's because, like I said, I made a copy and enlarged maybe. Okay, to find what we are actually finding here is the scale factor. To find scale factor, you always do the image divided by the pre-image. And remember, it's been a while, but pre-image is where you started from. Always image divided by pre-image. So A prime B prime is 3.5 divided by 7, which is 1/2. A prime C prime is 2.5 to 5, and that's 1.5 as well. Not 1.5, sorry, 0.5 or 1/2. And B prime C prime to BC is 2/4, which is 1/2. Notice these are all the same. In order for this to be a dilation, they all have to be the same. The side ratios are the same in a dilation. This is also the scale factor. If it is between 0 and 1, the shape got smaller. If it is larger than 1, the shape gets bigger. All right, and I'm going to just go ahead and tell you what the measurements are. I'm not going to get a protractor out, but you should pause the video and measure the angles. Get as close as you can. As long as yours adds up to 180, you should be okay. But the point is, the angles are the same. In a dilation, the angles are the same. the sides are proportional. That will come more in handy later. Sides are proportional, angles are the same. Let's open up and actually talk about this a little bit more. All right, we're actually going to get some definitions of scale factor, center of dilation, etc. The center of dilation is the fixed point about which all other points are transformed by dilation. So there will be a center. Normally, you're used to things having a center, like when we rotate, it had a center around the origin. Sometimes it was a center around a point. That's what we're going to be finding. Also, the scale factor is the ratio of lengths of corresponding sides in the image and the pre-image. We just kind of found that on the front. Dilations preserve angle measure, betweenness, collinearity, and orientation. Dilations map a line segment to another line segment. That's where I said a minute ago, if it was isosceles triangle, it'll be an isosceles triangle. That's what this is saying. Dilations map a line not passing through the center of dilation to a parallel line. Okay, let's look at example 1 and determine whether or not this is a dilation. And if it is, let's find the scale factor. Does it preserve angle measure? So if we measure all these, does it preserve them? Yes. Does it preserve betweenness? Yes. Collinearity. Is A and C are in the same line? Are A prime and C prime in the same line? Yes. Orientation. Did this flip around anyway? No, so it preserved that, yes. So that means we need to find the scale factor. And by the way, yes, it is a dilation. The scale factor is, as I said on the front, the image length divided by the pre-image length. So we're going to pick one side, since we know it is a dilation, and find this. Let's start with AC. Let's just do, and it's image, which is AC, sorry, A prime, C prime, divided by AC. We need to find A prime, C prime, and we're using the distance formula or the Pythagorean theorem shortcut, and I'm going to use the Pythagorean theorem shortcut, which is the square root of 1, 2, 3, 4, 5, 6, 7, 8 of 8 squared plus 1, 2, 3, 4 squared divided by AC 1, 2, 3, 4. No, sorry. Yeah, 4 squared plus 1, 2 squared. Okay, yeah, we got to keep going, make it as simple as possible. 8 squared plus 4 squared is 80 over 4 squared plus 2 squared is 20. By the way, if you have a square root divided by a square root, it's the same as having 80 divided by 20 all in the square root. 80 divided by 20 is 4. The square root of 4 is 2. So the scale factor is 2. Yes, sometimes you might have to do this. That is okay. We're going to talk about it and learn it while we do this. Okay. Glue this in on 96, and then we'll do the second foldable. Where we're just going to keep doing more of these at first. All right, the second foldable, which will be on 97 later. Go ahead and fold it in half. And we will start on it. Okay, so we're going to do some more examples like that, where we're going to determine if the transformation is a dilation. If it is, we're going to find the scale factor. So we could go ahead and we could measure all the angles. We also, though, can just look at the sides and determine if they are in a proportion to each other. So that's actually what we're going to do. So we are actually trying to see if all of these proportions come out the same way. So I've got, remember I said it is image, so AB over pre-image. I gotta flip those around. A prime, B prime over AB will be what we are looking for. It's one set of sides. I will be looking at B prime, C prime over BC. And then we will look at D, CD, C prime, D prime over CD. Sadly, the more sides you have, the longer this will take. That's okay now. And last, let's just put it down here. We have A prime, E prime over AE. Some of these you will be able to tell whether they are or aren't pretty quickly. Like if we had one that looks like they're not, I would probably find that ratio first. Let's go ahead and start with these, though. We are going to have some square roots here because they are not horizontal or vertical like these two will be. Alright, so A prime, B prime. My x, 1, 2, 3, 4 and a half squared plus 1, 2, 3 squared over the x is 1, 2, 3 plus 2 squared. And I do need to simplify those out. Your calculator will do it for you if it comes out as a whole number. So 4.5 squared plus 3 squared over 3 squared plus 2 squared. Oh, and I got 1.5. I'm going to leave that as a fraction of 3 over 2. So 3 over 2 is what I'm hoping I get for all of these. If I find one that is not 3 over 2, then I do not have a dilation. If all of these come out with 3 over 2, then I've also found the scale factor. So B prime, C prime from here to here. 1, 2, 3 for the x values. And then 1, 2, 3 for the y values. Okay, BC. X is 1, 2. Y is 1, 2. I hope you see the similarity between these two, but we'll check. Squared plus 2 squared. You know what? I put the wrong thing. Let's move over and put 2s instead of 3s and a 3 instead of 2. There we go, 1.5, so it's also 3 halves. So I have to keep going if I have the same thing every time. So let's look back over at C prime, D prime now. I like this one because it is it's horizontal, so we just count. C prime, D prime is 1, 2, 3 units long. And CD is 2 units long. I don't have to reduce. It's exactly what I'm looking for. Okay, now let's look at D prime, E prime. I've got 1, 2, 3, 4, and a little half there, so 4.5 over 1, 2, 3. We do need to reduce that, just to check. If you set it up as a fraction to begin with, it will always give you a fraction out, or I said that and then it won't. If you have a decimal in there, it always gives you a decimal. 3 over 2. So we're good there. Okay, let's see about A prime, E prime. Last one we've got to do. Okay, A to E, I've got half. So 1.5, 2.5, and then another half, so actually 3. So 3 squared plus 1, 2, 3. I have to make sure I type it in right. Hopefully you've seen I've got some problems doing that evidently. Okay, and AE, 1, 2, so 2 squared. Plus, I go up 2, so 2 squared. These two are the same, so I don't even have to type it in. I know it's 3 over 2. So the scale factors, the answer is yes. This is a dilation. With a scale factor of 3/4. 3/2, sorry, not 3/4. I found that because all of them are in the ratio of 3 over 2. Alright, let's look at number 2. I can kind of tell off the bat this is probably not going to be a dilation because this one looks wider than this one does. I do have to have proof that it is not, so I'm going to have to find the ratio just to see what's happening. But let's do the sides where we don't have to actually use Pythagorean theorem or distance formula. So we would need to find A prime B prime over AB. And B prime C prime over BC. Now, if it turns out these two are correct, we are going to have to find, or are the same, not correct, we're going to have to find the third segment length as well. So A prime B prime is 1, 2, 3, 4 units, and AB is 1, 2, 3, 4 units. So their current ratio is 1. Okay, and then B prime C prime, 1, 2, 3 units, 1, 2, 3, 4 units. These do not match. So no, this is not a dilation. We do have a couple more examples. They touch on, we've got the scale factor found. We also sometimes have to find the center of dilation. Okay. So these examples are actually talking about when we're going to find the scale factor, but we also are going to graph and we're going to find the center of dilation. So we have a rule here. It's been a while since we've had this, so in case you have forgotten what this is our rule. This is our coordinate notation. Don't forget what that means. It's coordinate notation. What that means is we take our x's, we take our y's, we multiply them by 1.5. So to get g prime, I have 1.5 and negative 3. 1.5, negative 6. I'm just multiplying. 1 times 1.5. Negative 4 times 1.5. 4 times 1.5. Negative 2 times 1.5. I'm going to graph both. I'll graph this one in black, this one in red. I am going to go ahead and tell you, though, the scale factor, if you are given coordinate notation, is always here. So those match. Scoot that over a little bit. So my scale factor is 1.5. I will find the center of dilation in just a few, but I have to graph it before I can find the center of dilation. Okay, now that we have talked about coordinate notation, found the scale factor, found our new coordinates for the image, we now are going to talk about the center of dilation, which is here. So this is called center of dilation, and we're going to find that by graphing the pre-image and its image. So that's our last step here, is to find the center of dilation. So we're going to scoot over. We're going to graph this to find the center of dilation. So the pre-image, we have 1, negative 2, G. I was looking at the label of the other points. G. And then I have 1, negative 4 for H. 4, negative 2 for J. I'm going to connect these to make our triangle here. Okay. I then need to graph the image points. So G prom is 1.5, negative 3. H prom is 1.5, negative 6. And J prom is 6, negative 3. So I've got my two figures. To find the center of dilation, I'm going to create lines from each set of corresponding angles. So G to G prime. You need to be extremely careful, because I didn't do it as good as I needed to make sure you are connecting them exactly, because if you don't, then you're not going to get the correct center of dilation. So there's one of them, G to G prime. Right next, H to H prime. And J to J prime. Okay. Where the three line segments connect is our center of dilation. So this one is 0, 0. The standard is normally that the center of dilation is 0, 0. And we did look out there that one is the center of dilation. We're going to do another one. I'm going to zoom out so you can see it, so you can practice it on your own before we do it together. Let me zoom out so you can see it. So here's the next one. Give you a second, maybe you should try that one out. Okay. The first thing we're going to do is plug into these to find our image points. Notice this is 1/3. It's less than 1. That means our points are going to be smaller. 1/3 of negative 3 is negative 1. 1/3 of 3 is 1. 1/3 of 3 again is 1. 1/3 of 6 is 2. 1/3 of 3 is 1. 1/3 of negative 1 is negative 1. Again, like I said earlier, the scale factor matches this coordinate notation. That means our scale factor is 1/3. You can also find it like we did earlier in this lesson. So likewise, to find the center of dilation, we have to graph it. So L is at negative 3, 3. M is at 3, 6. And N is at 3, negative 3. And we need to graph the image, which should be smaller because it's less than 1. Negative 1, 1. L prime. 1, 2. M prime. And 1, negative 1. N prime. Draw that one. Again, we're going to connect our points. See what's going on here. See what our scale factor. We already have the scale factor. See what our dilation, center of dilation is by connecting. So I'm connecting M to M, L to L. When I connect L to L and L prime to L and N prime to N, they're actually the same segment. Again, this one met at 0, 0, so this one just happens to be 0, 0 as well. So remember, to find the center of dilation, I'm going to connect M to M prime and L to L prime, N to M prime. I have that. It just so happens that L to L prime is the same as N to M prime, but they do meet at 0, 0. Which is it is a coincidence. It does happen sometimes, not all the time. There is your lesson on dilation. All right, now that we have finished that one, go ahead and take it and glue it to 97 in your notebook, and then after you've glued that in, if you haven't labeled it, I sure hope you have by now, label it 11.1 dilations, but if you haven't, do that now, and then start on the assignment that you have been given for this lesson.